We are going to talk about covalent bond. So what is a covalent bond? So we say a covalent bond is a bond that occurs between non-metals, okay? And it involves equal share of electrons. So you have two non-metals, and the two non-metals are going to share their electrons equally. So covalent bond can occur between atoms between atoms which are similar. For example, we can talk about hydrogen. Hydrogen gas is made from the covalent bond or covalent bonding between one hydrogen atom and another hydrogen atom. And it can also occur between atoms which are different. In water we have hydrogen atom and we have oxygen atom. So elements which are covalently bonded tend to form molecular structures. For example, we've talked about hydrogen gas, we have oxygen gas, okay? So we can represent covalent bonds using short straight lines. So this single line represents a pair of electrons, okay? Meaning we have two electrons. If you see two short straight lines, it represents two pairs of electrons. Three means what? Three pairs of what? Three pairs of electrons. Okay? And it is what you call what? It is what you refer to as a single covalent bond. This other one, the one which has two short straight lines, we indicating that we have two pairs of electrons, is a double covalent bond, while this one is a triple. It shows that we have what? A triple covalent bond in our molecular substance. Covalent bond. So now we are going to use diagrams to represent our covalent bonds. Now, let us talk about hydrogen. We said the first thing that you need to know is the atomic number so that you can know the configuration. And we said ionic compounds, we draw all the energy levels, but covalent compounds or in covalent bond, we only draw the outermost energy level. So for hydrogen, the atomic number for hydrogen is what? 1. So configuration is what? 1. So we are going to draw that you draw the first circle, you put your hydrogen, that is the nucleus, you put the symbol of your atom so that you can know what that represents. So that is your atom hydrogen, and the first energy level has how many electrons? 1. Okay, so we have that one hydrogen there. Okay, one hydrogen atom. This is our hydrogen atom covalently bonding with another hydrogen atom with also one electron in the outermost energy level, because the configuration shows that we have one electron in the outermost energy level, okay, to form our molecular compound, which is now the hydrogen what? The hydrogen gas. And remember, we said here we have what? Equal share of electrons. So what is going to happen here? You're going to have your one hydrogen atom there, okay, sharing its electron, this one electron, with this other hydrogen atom. And this other hydrogen atom is also going to give the equal amount of electrons that it has been given, which is 1. So we are going to have that. Now this is this other hydrogen atom, okay, combining, because they are bonding with this hydrogen atom, and it's going to share or give this hydrogen atom its electron. So as you can see here, you have 2 electrons, and these 2 electrons are for which? So these 2 electrons, so this leading to, so now this leads to the formation of what? Now this is what you call the hydrogen gas molecule. For water, the electron configuration of hydrogen is 1, so the outermost energy level is 1. When you come to oxygen, the atomic number of oxygen is what? 8, so the configuration is 2:6. This means that oxygen needs to have how many electrons for it to be stable? 2. So this means this is the structure of our water molecule. You have there, so this is O, the symbol of oxygen, is our nucleus, okay? We said we only draw the outermost energy level. So in the outermost energy level, you have how many electrons in oxygen? You have 6. So we are going to draw our 6 electrons like that, okay? We draw it like what? Like that. And now this oxygen is bonded to two hydrogen atoms. So we are going to draw our hydrogen atoms here. You have your hydrogen atom. Your hydrogen atom has how many electrons? 1. So the hydrogen atom is going to donate 1 electron to oxygen, or it's going to share 1 electron to oxygen, okay, because we said we have what? Equal share of electron, while the other hydrogen, remember it is H2, so we have 2 hydrogen atoms, one with the electron configuration of 1 and another with an electron configuration of what? 1, meaning these 2 hydrogen atoms are going to donate the electrons to oxygen, and oxygen is going to do the same by donating 2 of its electrons, or by sharing 2 of its electrons. So this is one of the hydrogen atom, and you're going to have another hydrogen atom pair that is going to share 1 of its electron, and in turn it's going to receive 1 electron from oxygen. So this is your structure of your water molecule. If you're talking about chlorine, chlorine has the configuration of 2:8:7, meaning the outermost energy level has 7 electrons, requiring how many electrons to attain stability? 1. Chlorine is a diatomic molecule, so it is Cl2. So if you're talking about chlorine gas, we will draw the outermost energy shell having the 7 electrons in chlorine. So the nucleus with chlorine, the symbol, this one with, now we draw the 7 electrons, okay? And we've said we have equal share of electrons. So remember, this is the atomic, meaning it is made up of 2 chlorine what? 2 chlorine atoms. So one chlorine atom is going to donate 1 electron, and another is going to donate 1, because it only requires what? 1 for it to be 8, for it to attain what? Stability. So this is one of your chlorine atom that is going to bond to another chlorine atom. And this chlorine atom, we have said it's going to share how many electrons? It's going to share what? It's going to donate 1 electron for it to attain stability. So we are going to draw our remaining 6 electrons.